All right, let's get right into it. What do you guys want to talk about today? I
I
think
don't know.
that Ashley, you had that PR that you brought up. Let's see if I can
Yeah,
find it
so
again.
there was a minor PR for adding the AWS handle regions decorator to the IAM calls, um, just to be able to take advantage of the handling for unauthorized exceptions. Handles that more gracefully.
Okay. And then let's see, I think that you had another PR also with the ELBs, right?
Yeah, the more interesting one is the ELBs adding some more information around actions, rules, and so forth. And you mentioned possibly rearranging that to use the new schema, was it?
Yeah. And then that would be a good segue for me to talk a little bit about some of the changes I've been making for, well, some things that we've been learning about adopting the data model. And we can talk a little bit about that here. Um, yeah, I think that could get us started, and then we'll just see where that takes us. Anything else that we should pencil in here to make sure that we get to it? Or is that good?
If we have time, the discussion about the making cartography concurrent.
Oh, okay. Yeah.
That's a good one.
Yeah. Okay. Sounds
Yeah.
good. Let's see. So for this one, um, you wanna kind of give us an overview, Ashley?
Yeah, so the AWS handle regions decorator modifies the functions, handles certain exceptions, and retries them gracefully. And as a happy side effect, that allows us to handle unauthorized exceptions when trying to get policies. It wasn't applied originally to the IAM, all of the IAM get functions, because they return decades and decades of lists and all kinds of things instead of a plain list. So this PR modifies the decorator to use the type hints to introspect that and return a empty value of whatever type it's expected to have. And as I said this morning, it's failing tests because the test function isn't actually doesn't have a type hint, so it doesn't know how to return a value for that. So I've just been bashing away at that for the last 10 minutes to see if I can see how to modify that. It's annoying.
You've been adding type hints to tests.
No, well, I've been testing that, but that involves its own issues.
Okay.
So
Okay.
this works in the real functions. It works fine. In the test functions, which don't have type hints, it complains because it now doesn't know what to return.
What about you said you want to handle a situation where the role that cartography is using is not authorized to do this particular fetch.
That's it.
Can you tell us about that situation? Because ideally, cartography is authorized, but we
Yeah,
need to allow it to run in situations where it's not authorized all the time. Right?
yeah. So basically, we have SCPs, service control policies, that override any policy that we can apply, and essentially, there's an SCP for anti-escalation that prevents you from accessing or modifying or anything with certain IAM policies, and that's just a boundary that we have in place to ensure that nothing can review those policies. So that's not something I can modify. I can't override that, and it doesn't show up if you just try and check your permissions, because SCPs work outside of the usual IAM policies.
Okay.
Got it. Okay. Yeah, and then I guess yeah, like Ashley said, the IAM code, but typically in other places of the code, we add in this like a AWS handle region catch-all thing that includes a bunch of different exception handlers for permission problems. And so IAM didn't have that, and so this adds it, and then I guess there's some type confusion now with the way that we're testing it, and yeah.
So I like the idea of this decorator to handle those situations. But personally, and yeah, feel free to weigh in, y'all. But prefer to have this new functionality, right, to handle that type of permission area in a separate decorator. Just because like it, handle regions doesn't necessarily mean handle regions anymore. If we add this new feature, so yeah, that's why.
I mean, we
Yeah.
could rename handle regions. And so now that it's kind of evolved into like a different purpose or as a catch-all.
Yeah, but I like the idea of compositions, right? We keep handle regions the way it was before and add this new decorator, and then maybe a new decorator that's composed of both of those decorators.
Yeah, but at the same time, it's like you start to have method signatures that have like 5 different decorators in there, and it's like, okay.
I feel you, but at least I mean we could refactor that later, I think. But yeah, personally, I prefer to have it in a separate decorator. But yeah, any other opinions?
Well, as it happens, this decorator doesn't pass tests now because of the typing issue. I think it would be cleaner to have a decorator that returns a dict and just use that here, and then have the specific functionality we want. So I'm happy to drop this and raise a new PR that does that, introduces a new decorator. Naming is the hardest problem in computer science, so if anyone else wants to tackle that, I'm all ears.
So what's the error that gets returned again?
You get an unauthorized access denied exception, which is one of a few different exceptions that handle regions handles.
Yeah, it shouldn't. Well, yeah, I guess I mean it should, right? Because like that's the exception you get when you can't access the region. Jeez. All right, we can put it in. It's okay. Okay, all right. You can keep the PR as is. I'm not that strongly opinionated, but I just prefer it in a separate one. Still,
I agree that it's not obvious to someone who's new to the code base like me that handle regions is actually doing this or why I've used it. But yeah.
Okay, so what's the decision that we're making here? Are we going to include this in handle regions, or are we creating a separate decorator?
I think the decision was we'll keep it there. But if you find that it's not really possible with the way you're trying to test it anymore, then yeah, you can put it in a separate decorator. I mean, you're saying that might be easier to test in a separate decorator or to make the test pass?
So,
okay.
Yeah, because the whole introspection, looking at type in to generate an empty type is kind of funky. I don't know if that's a very Pythonistic way to do things. So a separate decorator that returns a concrete type might be simpler anyway.
Okay. Yeah. Yeah, I think that maybe needing to do like all kinds of unions on there that makes it messy, and then that's another problem in itself. Okay. And you're asking like what should we name the new decorator? I don't know, AWS handle SCP.
Handle not authorized. Or handle unauthorized.
Handle unauthorized dicts because it has to be distinguished from handle regions by returning a dict on failure rather than an empty list.
Can you so Someone internal here at Lyft, you might have seen his PRs once in a while. Named Anish. He has some opinions on making functions like, I guess, polymorphic, like being able to return multiple different types. Yeah. Personally, I'm okay with you being able to allow it to return multiple types, but yeah, give it a shot to see if you can just see what you can do. All right. And yeah, we'll leave it at that.
Yeah, I don't have a very strong opinion here. So I guess the decision here is like adapt it into AWS handle regions, but if it ends up being way too difficult and you find yourself like smashing your keyboard against the wall, then just create a separate decorator for it. And then whatever you name it, I mean, again, no real strong opinion here either. Something close to the purpose, I guess, and that's probably good. Yeah,
Sounds good. Cheers.
cool. Let's go on to the next one. Okay, so ELB changes, and this one is a little bit overdue. So I'm sorry about this. We're behind on reviews, and you're adding in you're adding a new path basically, right? So this new rule and an action that applies to an ELD v2, if I understand correctly.
Correct. Yeah. So we're recording information about the rules on the relationships, and then adding a new node for actions. And the result of that is that we can actually then assess an HTTP request against all of the load balancers that we know and understand how an ALB that, for example, does a redirect on a certain path will actually then handle the request rather than just linking it to everything that it's connected to. That was the goal.
Okay, and then the action has like these different fields on it. So, okay, so it can be something like forwarding it or doing other, like a redirect or some other kind of response.
That's right. So there's a few shared fields and a shared type, but individual actions are subtypes according to what they are with different properties.
Nice. Yeah, and then so this is helpful. This is cool. We talked a little bit before this meeting about this change, and the tricky part is we're currently trying to do. We want to introduce this. It's a little tricky to do since the EC2 modules are being changed at the moment right now to be refactored toward this new data model, and the code currently adds in some, I guess, queries like write actions in the sort of quote unquote legacy style, the old way that we've been doing it. And as much as possible, since you are introducing new node types, I think that we can probably work together to write this in the new data model style. Since you got a new node type, it's going to be attached to an existing node type. I think that should be fairly straightforward to do. And yeah, then you get like all the conveniences of like automatic cleanup jobs. You can probably like get rid of this entire file, for example. And then I can kind of talk a little bit about, I can kind of give like a brief overview about how we're doing that, how we're thinking about that, and some kind of pitfalls that we've been encountering recently, if that's helpful. Yeah, so let's see. So first of all, like a supportive of the change, let's definitely get this in. But it may be a little bit delayed since at the moment we're in this weird state where it's like, okay, we can't quite adopt in I don't want to adopt in new code that uses the old style because we're gonna have to go back in there and then change it to the new style. And so it's a transition time, and so I realize that it's gonna be a little bit of a not the best dev experience, but we'll get through it. Okay.
Yeah, I'm keen to avoid adding legacy. There's enough of that in the day, in the usual work.
Well, and also like if you have more, I'd say that we're early enough in the process where if you have feedback for what the new data model looks like, then let's absolutely incorporate that in there and then make the changes sooner rather than later. So I think that what you have here, as far as the code goes for load balancers, I mean, this is straightforward. I mean, you got like your get, okay, and then you got getting a bunch of your list of dictionaries, and then yep, and then you're adding these relationships. What do we got? Yeah, okay. What's the best way to do this? Okay, so the way that I'm sort of thinking about it is you're introducing a new action, and then so what I would do is I would probably let's see, where's merge? Where your merge is at? Merge action. Endpoint. I can't find it, but oh, here we go. So something like this, where this is a clear example of like you have a new entity called a ELB v2 rule. We would create a node schema for that ELB v2 rule, and then we would introduce all these properties on that, and then we would define relationships on the ELB v2 rule data type, and one of those relationships would be something called attached to, where it would be attached to a listener. And then so it's going to match on that listener. How is it going to match on that listener? It's going to match on that listener based on a property. It's based on the ID of the listener, and that is going to be the ARN. And then so we're going to make sure that they're in the dictionary that is currently being processed. To load that to the graph, there will be a key value pair on the dictionary that includes this listener ARN, so that the data model will know, all right, well, I'm going to go try to match on an ELBv2 listener. I'm based on this property, and then I'm going to draw this to the graph. And that's sort of what will happen behind the scenes. And let me show you what an example that'll be somewhat similar. So I'm actually going to transition into sort of the next topic, if that's okay, since this is is probably related to the changes that need to happen here, if that's all right. All right, so if I go to, let me see. So I'll go here, and then I'll go to, just really quickly, on the dev guide, how to write new mental module. Yeah, and then so the basic idea is that you have a load function that you're going to put your data type into. It's gonna, this is like our,
Alex.
this is a general purpose load function.
Alex.
Oh, I did it again. Okay, good. Thank you for catching me. I always forget. But yeah, so you're going to have like a load function, and then you're going to pass it the schema object that you define. What is that? So a schema object will look something like this, like I said. So in this case, it would be a ELB v2 rule or ELB v2 action. You're going to give it that label. You're going to define one or more properties on it. And so with the node properties, it's going to have a class that looks like this. And it will also have something that we call a sub-resource relationship. I'm open to changing these names. They came up in like a number of Slack threads that are now very difficult to go search back because we're trying to use the free version of Slack. We can talk about anyway. I'm getting sidetracked here, but with the sub-resource relationship, what this is that we want to try to tie every one of these schema types to a billing unit. So in EMR, the billing unit is an AWS account. In like an Okta group, the billing unit would be an Okta organization. And then that's the idea. And then so the reason for having something like this encoded in our schema is that when we do the automatic cleanup jobs, we want to make sure that we are cleaning up EMR clusters one account at a time. We don't want one job to be deleting EMR clusters in a completely separate account, because that introduces all kinds of different race conditions and other problems. So we put that into the data model so that the module developer does not have to worry about subtlety like that. And you put the properties here. There's some couple of different things going on here. So the properties will define, this is the name that will be defined on the node itself. So you're going to create like this is going to be called security configuration. And we have a data type called a property ref, so a property reference, where what this is, it'll say, okay, well, where on the dictionary that is currently being parsed right now will I find the value to write to this property? So we're going to go look at the current dictionary for a key called security configuration. And then we're going to go index into that dictionary with this value, and then grab it and then write it to the Neo4j node at this property. And there's some little quirks here where, well, last updated, the way that cartography queries are written is last update is usually provided as a keyword argument instead of, and it's not like it's not included on every single dictionary. It's not different per dictionary. It's going to be like a set in the keyword argument. So last updated, you'll say like in the property ref, you'll specify set in keyword arguments equals true. And so let's see. So this and okay, here we go. The relationship, like I mentioned earlier, you'll define something like you'll say, okay, I want to go to an AWS account. For this EMR cluster, I'm going to try to target an AWS account. I'm going to say that I want to match on an AWS account based on the account ID. And then I'm going to have a direction for where I want the relationship to point to, and then what I'm going to label the relationship as. And you can go into the details about how that works. And then like if you get confused, then write us on Slack. But what I will show right now is like how all of that gets written to a query. So we take all those data types and then we end up generating the Neo4j queries. Yeah, if I can find it, test, cartography, data. Did I do it here? Under graph, yeah, graph, test query builder complex. Yeah, so that's the basic idea where you build it. It'll tell build ingestion query. You will give it a schema object, and then at the end of all of that processing, build ingestion query is going to have a template that generates and spits out a query that looks like this. So it will do this unwind pattern so that everything is all batched up nicely. It will merge it. It will set the properties that you define. It'll parse that data model. And then it'll kind of do this neat thing where if you have multiple different relationships defined on your schema, it'll generate it in this construct for Neo4j where this is kind of nice where we got one relationship, a second relationship, and a third relationship. And then so you have to wrap it like this in Neo4j because Neo4j is weird where if in the dictionary you don't have all of the fields defined that it is looking for, then depending on the order that this thing gets executed, it might like if for example, if say this ID happens to be null, if you don't have it in this construct here, then when Neo4j processes it right here, it'll just say, all right, well, stop. I'm not going to go and try to merge in the rest of the things here, even if you have, even if like the data is there in the dictionary. I'm not sure if that makes sense, but point is we dealt with all kinds of different weird edge cases and came up with this that seems to work for all kinds of complicated things, and it's been working pretty good so far. I did not want to make an ORM or like a light version of what is effectively like a poor man's compiler, but here we are. And then the reason why we did it this way is because we wanted to we have this real big problem where the code base is growing and growing. And as you've seen, it's like very error prone, right? Like you're handwriting these queries And there's lots of these easy ways to make performance really bad. It's slow to review. And then so we're going to slowly try to refactor everything into something where it's more sane.
Thanks, Alex. Demo again. Eric's saying something. Yeah, that's true. So all these situations that you might not realize when you're writing the queries by yourself, we try to, we have handled them already with the node schema model. Yeah.
Can you guys hear me?
Yeah, Alex, yeah, I can hear you.
Okay, cool. I do want to, anyway, so that was a little bit of an introduction to the data model. I do want to show one thing that, I guess one possible quirk that I figured out that might, let me show you. So one thing that is, that somebody brought up, maybe, I forget what his name was, but about maybe a year or so ago, someone from Okta did a hackathon on cartography and then tried to adopt it, and then gave very good feedback saying that, it's difficult to recognize what direction should I define my relationships, especially if I get myself into the situation of I have an EC2 instance, it's got a network interface, and then later on I'm going to call describe network interfaces. How do I reconcile the data known by describe EC2 instances versus describe network interfaces? Because those two API response types have different fields available to me. Like if you call describe EC2 instances, it's going to give you a list of network interfaces that is kind of like only having a small subset of all of the possible fields of a network interface. Whereas if you call describe network interfaces, it's going to have like a more thorough set of all of those properties. And how can we make cartography faithfully and accurately represent all of those things and then merge all those things into the right thing, where you have like an instance and then it's got like the interface, and then later on you call describe network interfaces and then it populates the interface that was previously created with the appropriate additional properties. Does what I say make sense so far? I'm seeing slight nods.
Sounds familiar.
Yeah, so the way that I've been trying to figure this out is we are starting to define things like like for example, this is a new class called a network interface instance. So there's a set of properties of a network interface as known by an EC2 instance. So put another way, an EC2 instance, when you run that describe instances call, it will let you know of the interfaces that are attached to the instance, but it will only know about a select number of properties, such as the DNS name and then the IP address, and not much else. On the other hand, you have something more complete, like the network interface itself, where the network interface will include even more fields. So we got properties returned by described network interfaces. So like it'll include like a subnet and then all these other additional properties. And I'm not going to go way too in the weeds here, but just bringing this up to let you guys know that this is something that we have been thinking about and we have a solution for. And that solution is to sort of create this sort of additional classes. So you'll have a interface node, and you'll also have an interface instance node, so that it represents two different ideas. It'll represent an interface as known by describe EC2 instances, and it'll represent an interface as known by describe network interfaces. These words have way too many syllables. My mouth is getting tired, but hopefully that makes some sense. And we'll be getting this merged in very shortly. I think there's maybe a couple of minor changes in here. Any questions?
Yeah, just to say what Alex said in my own words, we have a different data model for different return value schemas, and it works.
Yeah.
I
Yeah.
assume that
Go
that
ahead.
then gets merged by in the actual graph. That gets merged because you're sharing IDs and types for the two different schemas, or
That's right. They share
yeah,
a
beautiful,
common superclass. Yeah.
neat, very neat.
Yeah, the other alternative that I was considering before we decided to kind of split them up into two different classes, I was thinking I almost went and edited the query builder itself so that, you know what, rather than have me talk about it and stumble over my words, I will link to the specific issue where I wrote the entire bug before. It's easier if you read it that way, but because anyway, this class's way of doing it is a lot simpler than editing the query builder code. And because you just end up special casing a bunch of stuff, and it's like, oh, no. It's way more complicated.
Yeah.
Okay.
All
So
right.
that's that. Sorry, go ahead.
Oh, yeah, nothing. Just wanted to. I don't know if we did open the issue yet or not, but yeah, we do want to like maybe with Hacktoberfest, Hacktoberfest, right? That's what it's called.
That's like 2 or 3 months from now, but I'm glad you're thinking ahead.
Still though, like they started like a month early, I think, right? It's not exactly in October. But yeah, just refactor all the things. You can start with some of the easier ones, not necessarily AWS ones. Some of those were really complicated, especially IAM, as you've seen. So yeah, we want to just fix all those, and honestly, it'll fix a lot of issues we've seen where cleanup jobs just weren't really written properly in the first place. Yeah, that type of thing.
That's a good point. Yeah, that's a good call to action, because once we get sort of these initial patterns done with the refactor, we do need help. It's a big set of things. And then so like if other people are able to copy the patterns, or other people are able to come and help us refactor the rest of it after laying down sort of these initial examples, that would be super appreciated. We would super appreciate that. Yeah. Okay, I think that brings us down to the last thing on the list so far, and then that's on concurrency and fetches.
All right, cool. So I think most of us.
Do you want to share screen, or like, do you want? Should I bring up something in particular? Or?
Yeah. Just bring up the discussion page. I think that's it.
Okay.
Yeah. Thanks. Yeah, I think most of us are aware of the issue right now, or the discussion. Ashley, have you seen that discussion page? Yeah.
Yeah, just in brief, yeah.
Yeah. So that's the idea, and kind of like I mentioned with the refactoring, a lot of the old queries to use the new model. Like this is kind of another large refactor, but I think it's pretty straightforward, and I guess like low effort. I think for each individual item. Yeah, that's the idea. We convert the blocking calls and run them in separate threads, and any loops that are serialized we can parallelize, and yeah, we make it potentially 10 times or more faster. That's it, but we gotta like finalize some things. Like I've only done this experiment on a few different types of AWS APIs, like some of the IAM ones and the ECR ones. So, try this on a few more and see what other types of edge cases we haven't imagined yet, such as rate limiting. But we have a good idea of how we're going to handle the rate limiting too, with like kind of like a handle regions thing with the back off, right? and either linear or exponential, whatever. And I've tried both, and it's like very much the same kind of results anyway. So yeah, that's the idea. Um, as you might tell, like we're still kind of new to doing things asynchronous, and that's largely because like the AWS APIs themselves are not asynchronous. There are some hacky libraries that exist that can turn some AWS code into async, but I've looked at them already, and they admit in their documentation they don't work for everything, and it's still very hacky, and I don't want to do that to our users in the community. So I'd rather do this thing, which doesn't seem hacky at all, right? Because this is like official Python stuff here. Yeah. Does it make sense, right? Like converting, serial loops into parallel runs, or parallel or just concurrent um, functions. Does that make sense? Like, I hope I'm getting my point across to folks, and I hope it's easy to understand as well, right? Because like I said, it's going to be a pretty big refactorator to retroactively do this for all the modules, and we can start with one of the more costly ones, or potentially more costly one. I mean, everything is potentially costly. Depends on your environment, right? Like, if you got a million lambdas out there, yeah, you could see improvements there. Or if you got a million S3 buckets, yeah, you'll definitely see. No one has.
So in this example for ECR, like what's going on here? Like, what is the thing being parallelized?
So a couple of things actually being parallelized. So with ECR, what happens is how it happened before, you get a list of all the repositories that you have in your account. And then for each repository, you need to fetch some data about the images. And then after you get each individual image data dict, you still need to do some more fetches, right? You need and you can see a little bit later in the code where it tries to get, I forget the exact name of the property. Right, the part where it's get images. Scroll down a bit too, please. Not get images. The one where I return some big tuple. Like, scroll down. I think it's not in there. Oh, I'm thinking about buckets. Right. Okay. But yeah, what's going on in ECR is like, yeah, you get the list of images and then you get the image data, right? For each image, you get the list of repos, and then within each repo, you still need to fetch a list of image data dictionaries, right? And before that was all serial. So you had no idea how, you had no idea. It made its way to Python. Yeah. It's been there for quite a few years now. I think maybe about 10 years, if I'm not mistaken. But I haven't really used it too deeply because most of what we do here in Python is the async stuff is kind of handled with Flask, right? And it already handles requests concurrently, so we don't have to.
Wait, so with this, so previously we were running get images for every repository one by one, and then so now, how many? I don't know how async works. I don't know Python as deeply as I should. How many concurrent calls to get repository images is happening at once?
So right, this will run each call in its own thread. And there are by default 10 threads. We could make it more if we wanted to, but 10 concurrent requests at a time. So some requests might finish a lot faster, and once those finish, that slot is available, and it will slate another request for those empty slots. But yeah,
Nice.
still at most just 10 requests at a time. And different APIs, they might do their rate limiting in different styles from other APIs. That's just how it is with AWS services. And as we can see, which is why we need to handle regions thing, right? Because permissions, rate limiting, throttling, it's all different. It's all kind of, they're all kind of special cases, so you got to handle your way around them. But yeah, so with S3, there's actually like 3 levels of asynchronicity that we could do. I don't know if that actually makes sense. I'm probably misusing that word, but anyway, 3
I
levels.
think Daniel's got some questions that you put in chat. I think Daniel's got some questions.
Okay, is Python async/await susceptible to the global interpreter lock like concurrent code, or does it get around it because async is a different beast? Get it around the global interpreter lock. Around the global interpreter lock. So, I mean, yes, we are getting around the global interpreter lock in one sense. According to AWS docs, right, or Bodo docs, the session object is not thread safe, but the individual clients are thread safe, right? So we're using the client objects directly, not the session object directly in our concurrent code. So, right, the clients, they'll have their own mutexes if they need them, like for internal objects if they need them. And actually, I guess it's a little bit more clear why they use the mutex, because we use the paginators, right? And you have to spawn a new paginator, right? Every time you use the client for a specific API. So yeah, and that way, like, it's not the clients that, have their mutexes, it's the paginators that have the mutex, right? And even then, you're still handling a whole lot of the things like the next token, right? Manually in your own code. But anyway, does it get around the global interpreter lock? Yeah, I mean, it doesn't even, occur against it because, like I said, the clients are thread safe. And with async, what happens is, yes, there is still the global interpreter lock. There is still exactly only one one task being run at a time in the main thread, right? But since the async calls are and they're in their own thread, and they don't have their own do they have their own interpreter? That detail.
Yeah, but that's why it's a global interpreter lock. As I mean, I haven't gotten like extremely deep into Python, but as far as I know, Python has always had this problem with like multi-threading and all sorts of concurrent and parallel code, that because of this global interpreter lock, there's a limit to how much you can parallelize. So it's not even anything about AWS sessions or that kind of thing. The reason I ask is that async await is not technically like parallel CPU kind of code. So I've used it in like C# and JavaScript, so I know that what it does is kind of start a request but then relinquish control to something else. So it's not so much a matter of having individual threads dedicated to doing stuff than having kind of a thread pool that can be used for multiple things. So it could be the same thread, doing different things. But I was curious if this global interpreter lock still affects the asynchronous model if Python has async await.
I mean, I've seen the speed up, so no, right?
Interpreter lock wouldn't affect, because we're IO bound here, so we're going to be spending most of our time waiting for the API. So I imagine we're going to see heavy speed up there.
That makes sense.
Yeah,
exactly.
The real bottleneck would be the IO, the APIs, and like that's the big bottleneck here. And at least in testing in our environment with ECR in parallel, we've been able to turn all of our gets for that process from taking 15 minutes down to like 2 to 3 minutes.
Yeah, I mean, it'll be different for your environment, of course. Maybe you'll go down from 3 minutes to like 2.5, right? But
yeah, and then I guess this is an environment with about maybe 400,000 images in ECR, which it's not a lot, but it's also not small either. So
yeah, I think something like 1,000 repos. Is that it? Yeah, I think it's
around there. Yeah. So yeah, and then having I guess what I'm liking about this code is, I mean, this change that you got is, I mean, that's not that big for for two different modules. And then so the only thing to kind of navigate here is making sure that we're doing like effectively we're doing two very broad refactors at the same time. We've got this data model thing, and we've got performance enhancements coming in. When we get, so like all big refactors of big projects, we're going to be doing it little by little, and it's going to take time, and there may be rough edges, but I think the end result's going to be worth it.
Yeah.
Okay.
All right. So, I mean, next thing to do for this is to inbuild some rate limiting handling, and then or throttling handling, and then I think we're good to go with this. I'm so far that's like the only real like iffy thing about it. Okay, yeah. So we'll start with ECR, and then S3 buckets. Those are things that affects us the most here at Lyft, and some of the more easy examples that we can work with. And that'll definitely be a huge win for, I think, a lot of orgs out there. But the whole IAM module needs a big refactor first to use a new data model. Yeah.
And then I don't know, we're trying different ways to organize the project and whatnot, and to kind of communicate the things that we're prioritizing. So I guess on the roadmap front, we've got that concurrency. We've got ideas for refactoring to a data model. And the main reason, I guess the quote unquote business reason to refactor to a data model would be to standardize ID fields. Once everything is in a data model, it's significantly easier to make changes in broad strokes to different fields. And then so ID standardization has been a pain point of cartography for a long time, where it's like sometimes we use an ARN, sometimes we use like a particular asset ID, and then so let's try to be more consistent there. And yeah, are there other topics that anybody wanted to bring up for the recording? Otherwise, we can go into the part where sometimes otherwise we can kind of like just talk offline off of the recording. Yeah, what else do you guys want to bring up? Okay, cool. I'm going to turn off the recording then.